Okay. Now we have the last question. Question 10 is about topic 11, nuclear and particle physics. So question 10a, an atom of magnesium has the following particles: 12 electrons, 12 proton and 13 neutron. Question 1, calculate the nucleon number of the atom. So we want to find nucleon number A. And then question 2, given the mass of atoms is 24.98584 U, calculate the binding energy of the nucleus in mega electron volt. So we want to find the binding energy for the magnesium. So if we refer to the list of equations, in order to calculate the nucleon number A, we can use equation 86. So 10A, nucleon number A is Z plus N. So we have 12 plus 13, so we have 25. So we have solved question A number 1. Then we have question A number 2. Then for question A number 2, we are given the mass of atoms. So be careful. The question gives us the mass of the atoms. For magnesium is 24.98584 U. We want to find the binding energy in mega electron volts. So if we refer to the list of equations, in order to find the binding energy, we can use equation 88. The binding energy is mass defect multiplied C squared, whereby we have to determine the mass defect first. So kalau nak cari binding energy, kita perlu dapatkan mass defect dulu. So kita boleh cari mass defect delta M gunakan equation 87. Mass defect is ZMP plus NMN minus mass nucleus. Hati-hati ya kelas. Dalam equation ni kita perlu tolak dengan mass nucleus. Tapi kalau kita refer soalan ni, soalan bagi kita mass atom. So kalau atom dia termasuk elektron. So kita perlu dapatkan mass nucleus sendiri, di mana mass nucleus adalah mass atom minus total mass of the electron yang ada dalam atom tersebut. Okay, so untuk selesaikan soalan binding energy ni, pertama kita perlu dapatkan mass nucleus dulu. So the mass nucleus will be the mass atom given in the question minus the total mass of the electron. Sebab nucleus tidak termasuk elektron. So kita perlu tolak mass electron. So mass atom 24.98584 minus the numbers of electron we have in the magnesium atom is 12, and mass for one electron kita boleh dapat daripada list of constant. So kalau kita refer kepada list of constant, mass untuk electron adalah 5.49 to the power of negative 4U. So kita terus guna formula mass kita dalam atomic mass unit U lah. So, kita dapat mass nucleus is 24.979252 U. Then only we put it into the equation of mass defect equal to ZMP plus NNN minus mass nucleus. Okay, so the numbers of proton is 12. The mass of the proton is 1.0072777 U. The mass of numbers of neutron is 13, and mass of the neutron is 1.008665 U. So the mass of the proton and mass of the neutron, you can refer to the list of constant. You might refer to the list of constant. Okay, dekat sini. Okay, if you refer to the list of constant, okay, you boleh dapat mass untuk neutron dan juga mass of the proton here. Alright, okay. So, pastikan anda tahu di mana you nak cari nilai tersebut, dan minus with the mass of the nucleus that we have calculated from the mass of the atom, and then we will get the mass defect is 0.220717 U. Okay, so we have get the mass defect, then we need to calculate the binding energy. So, class, Because the mass defect is in U, so I can calculate the binding energy by just taking the mass defect multiplied with 931.5 mega electron volt. Okay, I repeat, kerana mass tu dalam atomic mass unit U, so saya boleh cari binding energy dengan saya terus ambil the mass defect multiplied with 931.5 mega electron volt. Why? Kenapa? Sebab kalau kita refer kepada list of constant, kita boleh tahu 1 U akan setara dengan 931.5 mega electron volt energy. Okay, jadi kita boleh terus darab lah. So we multiply with 931.5 mega eV, so kita dapat binding energy untuk magnesium is 205.6 mega electron volt. Okay, 205.6 mega electron volt. So mungkin some of you might wondering, dan teacher, bila kita akan guna delta MC squared? So kita akan kira binding energy gunakan equation delta MC squared, di mana sekiranya delta M kita adalah dalam kilogram kg. So delta M kita dalam kg, dan kita akan multiply with the speed of light kuasa 2, then we will get our binding energy in joule, dalam unit joule. Okay, so hati-hati dalam penggunaan formula untuk cari binding energy. So binding energy, kalau you nak cari dalam unit joule, mass defect you mesti dalam kg, you boleh darab terus dengan C kuasa 2. Tapi kalau kalau mass defect you diberi dalam U, anda boleh terus cari binding energy dengan anda darabkan mass defect dengan 931.5 mega electron volt. So question 10b, the activities of carbon-14 from an ancient fossil is 1200 decays per minute. Given the half-life of carbon-14 is 5760 years, so calculate the activities 3000 years ago. So the question gives us the activities is 1200 decay per minute. Dan kita perlu cari activities 3000 years ago. 3000 years ago means 3000 tahun sebelum tu. Sebelum tu it means the initial activities lah. Sebelum kan, so kita nak cari initial activities, di mana sekarang now is 1200 decays per minute. So if we want to solve the questions, if we refer to the list of equations, we are going to use equation 91 and also equation 92 lah, because from the half-life we can determine the decay constant, then this decay constant will be used in the decays law equations. A is A naught E exponent to the power of negative lambda T. Okay, so first kita akan cari dulu the decay constant. So the decay constant will be ln 2 over the half-life. So I didn't do any unit conversion, so saya biarkan half-life saya dalam years. So my decay constant for this question will be per years lah. So I will get my decay constant will be 1.2034 to the power of negative 4 per years. Kenapa per years? Sebab half-life teacher buat dalam years. Okay, so lepas tu kita akan gunakan equation A is A naught exponent to the power of negative lambda T. So sekarang the activities is 1200, so we want to find 3000 years ago. Ago means initial lah, sebelum tu. So sebelum adalah initial, so kita nak cari A naught, so decay constant 1.2034 multiplied with the 3 times is 3000 years. So when we do the calculation, we will get the activities 3000 years ago is 1721.72 decays per minute. Okay. Kenapa jawapan dia dalam decays per minute? Sebab activities ini kita tak buat penukaran unit. Kalau you refer soalan, activities 1200 ni dalam decay per minute. Jadi A0 pun dalam unit yang sama lah, decay per minutes. So the total mark untuk question 10 adalah 7.